Whether it's in the air, on land, the sea, or under it, the SimNet is your simulation network. Welcome back, everyone. Today, we are going to go over how to wire the new 3D printable Strike Eagle backseat cockpit hand controllers for DCS World. If you're not familiar with these plans, I have a video overview of the project linked below. If you're new to the channel, welcome. This is just one of the types of videos you can expect to see from me in the future. I love all things simulation, especially as it relates to aircraft, combat, or otherwise. You can expect to see more 3D designs for aircraft like the F-14 Tomcat, F-4 Phantom, F-5 Tiger, etc., as well as mods for the combat flight sim DCS World, like my Jester voice overhaul mod and other more advanced mods. I also quite enjoy milsim games like Squad and Arma, so there might be some of that sprinkled in as the channel grows. Thank you for being here. I hope you enjoy this sort of freeform video as we go over the wiring and assembly of the WIZO HCUs. If you do, please hit that like button and consider subscribing, as channel growth allows me to make more cool stuff for you, the simulation community. Without further ado, let's get started. Alrighty, we've got a few designs on the table here. To review quickly for some upcoming videos, we've got the B6 grip. This is going to be released for free. I think it's going to pair very nicely with the Authenticate throttle that's being worked on. It's a great design. It was used for the P-51. This is the F-18 Hornet grip. So this is based on a scan that I was sent from the Open Hornet team and right rudder, left stick. So this is a design that will also be releasing completely for free, as the Open Hornet project is a free and open source project. A bunch of great people, really active in their community, and if I can help out in any small way, I'm happy to do that. Participated with helping out with the trigger mechanism there, which is based on the B8 grip trigger mechanism, which I designed here for this grip. So this is approaching completion as well. Obviously, the version 1 I've published to Thingiverse for free. This will remain free. The wiring guide is coming soon. I'm just waiting on last few parts in a custom PCB that I found online and ordered. So this is coming soon. Obviously, there are two versions. This is for the F-4 Phantom. And then this other one here on the table is for the F-5 Tiger with the extension. I believe that is actually to scale. I pulled it off some images of the F-5 in the model viewer in DCS. So that extension is also going to be releasing. And the nice thing too there is that this is using the same connector again as the Thrustmaster and the Virpil bases. And if you have that 5-pin mini DIN connector, you can just wire up your own extensions, and they're quite solid. Works quite well for me. I've been using it in DCS for the F5 module, and that's going to be releasing fairly soon on the Thingiverse page as well. And then this one here I teased recently. This is actually the Mirage F1 grip. It's still a work in progress. I painted one up just for some cool screenshots, but this is currently just a work in progress. I've got the buttons, the paddle. The trigger mechanism is very, very interesting in the Mirage. It flips down. It's going to use the same connector as the Thrustmaster and Virpil grips. Again, that's the kind of base I have, hence the connection method. And then I've also been working on a magnetic trigger mechanism so that it stays down and triggers a limit switch when in the up position. So that way you can kind of pull down on the trigger with your thumb to spring it open. And when it does that, it releases the limit switch, which shows that it flips in game. So that way you can flip and be good to go. But today, what we're really here for, and thank you for letting me update you on kind of what's on the go. Today, we're here for these. These are the WIZO hand controller units for the F-15E Strike Eagle. They feature a pair of thumbsticks like you would find in a gamepad, like for PlayStation or Xbox, for the TDC, which is an analog potentiometer-based thumbstick. Now, the real TDC uses a force transducer. I haven't had the pleasure of finding one for less than a few $100s. So if anybody has a DIY solution for that, I'd be happy to see it and implement it into this design. But until then, gonna keep researching the thumbstick will do for now. Of course, pairs very nicely with the B8 grip, which is free if you really want that super authentic feeling F15E Strike Eagle WIZO experience. Those clamps as well on the bottom are free. I found them available for free on Thingiverse, and I've linked that on the Cults page as well. Now, you can use any kind of clamp you'd like. These are powered by 2 Arduino Pro Micros each, and I'll go into that in the wiring section here in a few minutes. But this is the secret sauce created by Dr. Jake for the RealRobots configurator and controller software. So that enables 2 Arduinos to link together to expand the number of inputs you have without requiring button matrix or any super complicated coding. All right, I'm doing away with the gloves because there's some very complex wiring here, and I just want to ensure that I can manipulate the wires effectively without singeing my gloves. So we'll go through all of the inputs here. We'll do a quick assembly first, and then we'll start wiring up the buttons and switches. And from there, there will be a quick overview. So first things first, I take the 5-way navigation switch and insert that into the base. This is for the coolie hat or the castle. This is a connection method that I've used in the past. If you've downloaded my B8 grip, you'll be familiar with this. So I use a piece of filament, 2 pieces of filament that feed through the open holes on the side, and they essentially pin the navigation switch in place so that it doesn't fall out. But it's not a permanent method like glue, for example, where you wouldn't then be able to pull the navigation switch out if it were to fail on you for some reason, or if you soldered it up at too high a temperature and then were not able to get any output from it. So I find these navigation switches are quite good. They're cheaper than the RJXKM or whatever Alps switches there that I've used in the past, and they're reliable. They do a good job if you need multiple of them in a project, although I will be updating the design later on to include options for those switches as well, as they are, I know, a preference for folks. We looked at the thumbstick assembly there. This is the 2-way switch, so this uses a 3-position toggle with off in the center, and again, using that pinned method. The trigger you'll be familiar with from the B8 assembly video. I use that for my B8, I use that for the F18 grip, and I'm using 2 of them here today for the WIZO HCUs. These have 2 holes in them. They feed in, again, a piece of filament or a piece of stiff wire, also a screw if you've got one of a 2mm width at the appropriate length. That is completely effective. Screw might be preferable for some folks, but in this case, I just use a piece of filament because it's readily available and I can remove it if need be. And if I want to keep it there permanently, I can just use some glue. This is the P1 push button. This is very similar to right or left sticks P1 push button. It is slightly different. I modeled this one up myself, so there isn't an overhang, but it's effectively the same thing. All of the parts are press fit. If something is too stiff, you can Dremel it out a little bit. If it's too loose, a little bit of glue is your friend. And then the clamps go in from the front or the back, depending on where you're clamping them. So to clamp to my chair, I usually insert the clamp from the front. But if I want to clamp to a desk, I'll insert the clamp in the back. And I left both of those options kind of open and available. So all of these pieces are, again, press fit. If something's loose, a little bit of glue is your friend. I just use kind of common hot glue. I think it does the trick quite well. Bit of a close-up here, as the top-down view isn't as high of a resolution as I'm using a webcam there. This is the thumbstick cap for the TDC. The final version, I might have an updated version that has a dome or a half dome like the traditional gamepad thumbstick, but I've just had some trouble printing it even with support, so that might take a little bit of time to sort out. Also a close-up here of the P1 style push button. Again, this is my own design, but very, very similar to the one that's available for free as well. And that just takes the hex nut and screws right in, and then you can attach the red cap. There are also black caps available. These can be found on Amazon, AliExpress, Mauser, you name it. This is the two position switch. It's a temporary on with off in the middle. And so that is assembled like so. And again, those two holes are there for filament, which keeps the switch in place. And this allows you to trigger, I believe, chaff and flares. And it's only on the right side hand controller, although I decided to build mine with one of these on both sides. I don't mind the expanded inputs. And I actually, on the left hand, I use that as a mic switch or a modifier. So one is all you need to be completely authentic. Two, if you'd like to have expanded inputs. This is the clamp. Again, this is free on Thingiverse. This is just one example of a clamp. There are many of these available. You could also purchase a C-clamp from a hardware store or something along those lines. A little bit of foam would also be helpful if you're connecting to something slick like a desk. The 5-way navigation switch is a through hole. These, again, you can get these from Adafruit. You can get these on Amazon. You can get these from AliExpress. You can get these from Mauser, DigiKey, you name it. I generally, if you're trying to keep the cost down to that kind of under $30 mark, AliExpress is your friend. If you don't mind and you're looking for something from an OEM, then by all means, go for the Adafruit or Mauser, that sort of thing. So kind of shove that in there. And another, again, piece of filament here feeds through the open hole on one side through to the other one. And there you can see it. And this very effectively locks the navigation switch in. I've pushed quite hard on these, and I have felt absolutely zero wiggle. Very, very little play in this. Reason being, the holes are slightly above the bottom of the switch. So when inserting these inserting the filament, the fact that the filament is slightly round actually helps to get to feed into those holes because they're just slightly higher than the bottom. This right here is for the B8, so this is going to be updated shortly on the Thingiverse page with the new trim hat assembly as well. The hats themselves are press fit, so it takes a little bit of pressure to get them going, but once they're on there, they're on there. And it feels quite nice. Again, it's not quite as, it doesn't have as much travel as something like an Alps switch, like those 8 ways. And I will have, in the wiring guide, I'll have that available as well. But they are plenty effective for this kind of project, especially if you're trying to keep the cost down. So, is it 75% as good as an Alps switch? I'd say yes. Of all the 5 ways available online, these are the best after the Alps switches themselves that Virpil themselves use. Okay, we've got two Arduinos. Again, we're using the RealRobots software. So that connects pins 2 and 3, ground and VCC together. So 2, 3, ground, and VCC are soldered together between these two Arduinos. And what that does is you can designate them each in software, and it allows you to expand the number of inputs without requiring a button matrix or diodes. We've got the thumbstick here. Again, the thumbstick consists of 2 potentiometers and a 4.3 mil tact switch. Potentiometers have 3 pins. The inside or middle pin of each potentiometer is the signal, and the outside 2 are VCC or ground. What this does is it allows you to essentially chain the ground pins together and then run a second wire off of that. So ground functions for both pins, and it allows you to run one wire off, which you can then connect to the Arduino. So that's that little curved wire that you see going from pin 1 or pin 2 to pin 1 or 3, and then 1 or 3 on the other potentiometer. And then the inside pin is signal, so that'll go to one of the A marked slots on the Arduino, so A1, A2, A3, A0. I think I chose A2 and A3 for this one, but you could choose any of the analog pins. And then I'm also chaining VCC together and running one off of those. So each potentiometer has VCC, signal, and ground. VCC and ground can be connected to each other and then have one wire run off of one of those pins as long as it's connected to the other one. And then the middle wire is the signal. The tact switch, it's got 2 or 4 prongs. So one of those is ground and one of those is signal. And those connect to a digital pin. All right, just feeding the wires through here, putting them into the base, and that connects quite nicely. And then I did realize here momentarily that if I'd already chained things together before putting the thumbstick in, that means that I wouldn't be able to feed them through. So I disconnected them and then connected them together again, and then just covered them in electrical tape to prevent shorts. So that's functioning well. We've set that to the side. Now we've got the 2-position switch. Actually, it's a 3-position switch with the center position being off, and it springs back to the off position, just like the real thing. And this is for the chaff flares 2-position switch or 3-position switch on the right side of the right-hand controller. Although technically you could put it on the left-hand controller as well and just bind that to something else. Okay, then we've got the 5-position navigation switch. So we've got that diagram, which is available online as well for 5-position navigation switches. We've got ground and then 5 inputs. Again, these are digital inputs. Again, if it's clicks, it's digital. And then that fits into, that's for the acquisition switch there. And then we've got the next 5-way navigation switch. Again, we're connecting ground and then 5 inputs, up, down, left, right, and push. I am tinning all the wires here, and I'm tinning the pins as well. And what this does is it allows me to form a connection just by applying heat and positioning the wires. Now, technically speaking, you would form a stronger connection if you didn't tin the wires and you wrapped them around the pin and then soldered the whole connection. However, that takes a little bit of time and finesse and patience, which in this case I did not have, but this has been working just fine for me for now. Although if you do pull on the wires, there's a higher chance that they could snap off. So at your own risk, use your own discretion here when wiring. The benefits and drawbacks of each method can be discussed infinitely online. So that was for the coolie hat switch there. So connecting these all, now I am taking and tinning a few more wires. Again, that's applying a very small amount of solder solder to the ends of the wires to ensure that they're straight. And this is for the push button. Now I'm using slightly shorter wires. The push button, I only need 2 connections, normally closed and common or ground. Alrighty, so as mentioned for this project, we're using 2 Arduino Pro Micros per controller. So the right-hand controller has 2 of these, and the left-hand controller has 2 of these as well. And the reason for that is the software that we're using, which is the RR configurator and controller software, respectively. What this enables you to do is to connect the SDA and the SCL pins on both Arduinos together, as well as one of the ground pins and the VCC pin. And it allows you to expand the number of inputs on the Arduino Pro Micro without actually requiring a button matrix. So if you've got a couple of these lying around and you don't have a bunch of diodes, you can connect to your PC and have an extended range of inputs that you can configure without requiring any additional, more complicated wiring, I would say. So for someone who's more of a beginner like I am, this was a more convenient solution for me. But if you're somebody who's very familiar with button matrices, you probably don't, you can skip ahead this part of the video. This is very much the beginner level and very much how I approached this and how I wired things up. Of course, you might do things differently, but this is how I did it, and that's how I'm going to cover it here. So essentially, we'll call one of the Arduinos 0 and the other one, we'll call it 1. You'll see in the RR configurator and controller software, that's important because you can address each of these Arduinos. And again, this is covering one of the hand controllers. So let's say the right hand controller, it has 2 Arduinos in it. And the way they are connected to each other is pin 2 connects to pin 2 and pin 3 connects to pin 3. Again, these wires can be soldered together directly. VCC connects to VCC and ground connects to ground. Actually, you can use any of the ground pins to any of the ground pins. As for the rest of the inputs, on number 1, I just distributed out the remaining digital pins. And for 0, I used analog and then digital for the rest as well. So all of these, essentially, if it clicks, use a digital pin. These are analog or digital, depending on what you connect to them. So if you connect a button to this, then it behaves as digital and you can designate it as such in the software. If you connect a potentiometer, then it shows up as analog. So for 0, I've connected the thumbstick. Again, the thumbstick has 2 potentiometers on it, and each potentiometer on the thumbstick has 3 little spokes coming out of the side, 3 little metal tangs. The center one is the signal, so that I connect to one of the analog pins. Again, there are 2 potentiometers on the thumbstick, X and Y axis respectively. So that one I wire up to A2. And then the outside pins are VCC and ground respectively. So in the case of, it doesn't actually matter which one. You can wire them up. Either one can be ground, either one can be VCC. You just need one of each. So let's do this one. We'll go to VCC, and then this one goes to ground. Same story here. This one goes to VCC, and then this one will wire up to ground. And then there is also a small thumb button on the thumbstick, and it's a square, and it has 4 prongs coming out of the bottom. As a rule of thumb, I take diagonals if I can, or the tangs that are the little metal pins that are flat-sided next to each other. So diagonal is the rule I tend to follow. So one of those, again, goes to ground. One of those goes to a digital pin, and that would be the click. So when you're pulling this up in the software, that thumbstick, little tacked button on it, little 4.3 millimeter tacked button, you need to make sure you have ground and a digital pin for those as well. And then as for the rest of the switches, the pinouts are publicly available. Usually when you purchase the switch itself, those just solder into the digital pins. And then it's very convenient and easy using the RealRobots controller software, because when you click, it shows up in the software. So even if you wire it up like I did, effectively haphazardly, you can just click the software, click the button on the controller, and then it'll show up in the software which button you've clicked, and then you can assign that as you so choose. The nice thing about the potentiometers too is if you don't get the full range of motion on the thumbstick, you can designate min and max values in that software as well, in order to effectively show what the min and max values are to Windows and then to DCS respectively. So again, 2 connects to 2, 3 connects to 3, VCC connects to VCC, and ground connects to ground, and you're off to the races. When you're configuring these Arduinos, you plug them in separately. So this one you designate as 1, this one you designate as 0. You can name them different things. So I called this one right controller expanded and right controller base, something along those lines. And then connecting the digital pins, the average button, right? It'll have connect digital pin, and then you want to connect ground as well. And that way the signal goes through. So that essentially covers the Arduinos and why we have 2 of them in each grip. Again, if you're familiar with button matrices, this is very entry level and just how I decided to approach this project. You might have a different or easier or newer or better way, but there's a million ways to connect a joystick to a PC. I just happen to like this one because it's worked for me in the past. So, all right, let's move on to the next thing here. All right, so from here on out, we've fed the wires through the grip, and we're going to connect them now to the Arduino. So for demonstration purposes, I fed the second Arduino wires through the back, and then the first Arduino wires through the front. So here I'm just connecting all of the digital pins, as well as connecting wires for VCC, ground, and then pins 2 and 3, which again are soldered directly to each other on both Arduinos. That's what allows them to communicate, and that's how the RR configurator and controller software, those are the pins that they use to communicate. Now, Dr. Jake has great videos on how to use his software, and I highly recommend watching those, but I'll happily provide a quick overview here in this video as well on how I aligned these 2 Arduinos and how I arranged the pins. Alrighty, so as mentioned, the RR controller software is what we upload to both Arduinos so that they can run the joystick library and essentially have input and communicate with the PC. So this is loaded to both Arduinos. As always, you want to ensure that you've got an Arduino Leonardo set as the board if you're using an Atmega 32U4 based Arduino Pro Micro. And then you hit this upload button. And once you hit this upload button with the Arduino installed, you will see a upload completed here. And at that point, you can disconnect the device and load up the next one. And then from here, we are going to fire up the RR Configurator software to assign our inputs. So here we select the correct COM port for our Arduino, And here you'll see I've named it WIZO HCU write 00, and this is address 0, so this is the first Arduino. And then on the right-hand side here, you can see all of the pins where you can now designate them. You can designate which button it is. So when you click the button, you should see 1 or 0, depending on whether it's designating. And then you can designate the buttons as well as the min, max, and dead zone for the actual analog pins as well. And then for the second Arduino, that would be address 1. And so I've called that WIZO HCU write 01. Again, you can configure both of these, and same kind of thing. You click or move the thumbstick or click the buttons and they pop up, and then you just assign them using the assignment on the right. And you'll see once that's assigned and you fire up the joystick tester, you'll see that. And then commit to EEPROM there. That just means that you've sent it to the Arduino. Now we've got the joystick tester here, and this is the final step, just ensuring that these are all firing up. So we've got the trigger, then the axis for the thumbstick that's centering nicely, the point of view hats with all the clicks, and finally the pinky button as well. So we're good to go. At this point, it will show up as a device inside DCS, and you can assign your controls, and you're off to the races. And there you have it, the completed WIZO HCU for the F-15E Strike Eagle. Thank you to all of you who have downloaded the design, liked this video, and subscribed. Your support enables me to make more cool stuff like this for the community. I cannot wait to see some builds. Keep an eye out for the B8 grip wiring video and the Mirage grip assembly video coming soon as well. Until next time, I'm the SimNet. Thank you.